Okay. I'm going to start the presentation. So let's get right ahead. So today I'm going to talk about an existing automotive manufacturing application and how we set up the project with our random bean picking solution, AccuPick. So we did it for a company called Mergon, and they are a plastics manufacturer in the automotive industry. So as you can see here, we have a shaker system that's being fed the parts into a feeder. So what's happening here is that we have a scanner, a Solomon stereo scanner mounted on the top right here. It's a 2.3 megapixel, 12 millimeter scanner. And so we have our scanner integrated with a PLC. And in the next video, I will show you how the whole setup works. So here we have a scanner that's taking a scan for each cycle. And these parts are shiny and reflective, and our Solomon Vision system is able to accurately get good point clouds and picking positions. So here, while the scanner is out of the way, we have our Solomon scanner taking images so that we save any downtime with vision. So in this second station, it's basically a station to reorient the part and place it in the plastic mold right there. And so the part has to be placed in this plastic mold in the same orientation each time. And then the plastic mold is moves on to final inspection and is dropped off in the chute. So right here, I'm going to be replicating some of this today in the webinar and going over AccuPick, our software, and show how we set up this project in our software. So Solomon is a company with 50 years of experience, and our vision systems department was open in the last 5 years, and we've gotten the Vision Systems 2019 Innovators Awards because of the ease of use and flexibility, being able to use multiple camera types and integrate with multiple robot brands. And our software is also able to perform different applications. So we are in the energy and power industry, system integration, automation, robotics, and a bunch of other industries. So our offices are located in Taiwan, China, in the US. So me and my colleagues are based in Los Angeles and Detroit, and we have Thailand and Vietnam. So we have headquarters located in Taiwan, which is where the AccuPick was initially developed. So as you can see here, we have a global network. We have customers all over the world, in Europe, the US, in North America, South America, Asia, and we are only growing and expanding with time. So I wanted to give you a little bit of an introduction about our software. Our software is basically the brain of an automation application. So we are able to integrate with different vision systems, so structured light scanner, such as our Solomon structured light scanner, time-of-flight cameras, stereo cameras, and laser cameras. So we are able to integrate with Connect and real sense depth cameras, which are useful if you do not need too much accuracy. So our robots that we're able to integrate with, as you can see below, there are a bunch of different names, brand names. You can see we are actually able to integrate with 20 different robot brands, and we are only adding more to the list with time. So we also able to integrate with major PLC brands such as Rockwell, Mitsubishi, Siemens, and Omron. Our applications go from random bin picking to AI-based inspection to cutting, gluing, welding, and to vision-guided robots. In this slide, I'm going to explain what our different applications are. So today, I will be using AccuPick 3D, our random bin picking solution, to show how we did the application in that video for Mergon. And so our other applications are Solve Motion, which is our vision-guided robots, which is for applications such as gluing, polishing. Solve Vision is our application for AI-based inspections, such as looking for defects, looking for irregularities. Solve Scan is just our 3D scanner. It is just our Solomon 3D scanner. So let me now show you our AccuPick interface and get right to it. Okay, so here is our flowchart of how we set up this project. We start with a capture block. So our capture block essentially is our camera. It's taking in the information. It's basically capturing the bin of parts and taking in the point cloud, 3D point cloud information. Then we move on to the PickDrop block, which is basically setting pick and drop settings for the robot so that we customize it to our needs. Our recognition block is where the heart or soul of our software is, basically our AI. So this is where we train parts, basically teach our software what a part is and what exactly we want it to detect. And then we train our AI model through deep learning. Our filters block is just where we set parameters to get the best pick point. And I will go through each of these blocks in depth. Our robot script block is where we set our missions for our robot and waypoints and customize it to be the best for the application. A display block is just, so this is just what we are doing using for this project, but we have different templates for different applications, such as if you need to use 3D and 2D camera, if you need to use a PLC, smart packing, and we could also customize it by creating our own flowchart. So let me go through this block. The capture block is where, so we connect our camera. So right here, we are connected to our Solomon structure light camera, which has 2 basta cameras. As you can see, the 2 serial numbers. And I've set these values up for our project as we found this to be the best possible for our light settings, best possible settings for our light settings. So here we could connect our robot and set GCP values. Through here, we can calibrate the camera and the robot. So we have different ways of calibration. And we have able to calibrate cameras that are either mounted stationarily or that are mounted on the robot arm. So it depends on what the application is again. Here we change projector light settings for our structure light scanner. And we are able to use a projector light as the light for the images. Here's where we are able to mess with our 3D settings and set 3D acquisition limits so that we limit the point cloud. So as you can see here, I limited the point cloud to just the bin so that I don't have anything else in the point cloud. So let's move to the PickDrop Config block. So here we're able to set pick settings. And set it to what we want to select. So, for example, here I'm setting my priority for picking is to pick the highest objects first, and then pick objects that are closer to the bin center, and then pick objects that have a small picking angle. And so if I had to go over every single part of our software, it's going to take a long time. So I'm only going to go through our important aspects of our software. Here's just a drop settings. Basically, we're able to set how we want our robot to drop the objects after picking it up. And here we're able to just work with a 3D model of the part if you need to. So let's go into the recognition block. This is where our AI works. So here I'm able to set an ROI, or region of interest, for the parts, or like where I want to detect the parts. And so you'll see here that this is where we've taken all the images for training. And if you see how we've annotate parts, you can see we've manually annotated parts here, but like for 200 images, this is going to take a really long time. So I'll show you how I annotate just one part. So for example, I'm going to I have, as I said earlier, this part has two sides to it, a top and a bottom face. So for a top face, let me just show you what it is. So for example, this part right here is a top face. So I'm just using a polygon tool, and I'm just going to mask the image right here. And guys, if you have any questions, please feel free to ask in the chat. We also have a Q&A at the end of this session, so you could ask your questions over the microphone. So here I basically just mask the part. Basically, I want our AI to detect this as top class. So now I am setting a direction angle. This is what I want the orientation of the part to be, which is important because you need a consistent orientation to be able to place the part place the part in the plastic mold with accurate orientation. So this is going to take a long time to do this for all these images. So I'm going to show you how we automate these annotations in our software called Blender, which is basically Blender with an add-on, Solomon add-on. Okay, so here is where we do our auto labeling tool. So this is where we are able to automatically generate. We are able to generate automatically generate annotations. So when I create a new project, I'm able to I get these folders generated, and as you can see, I put in a background which is basically our empty bin full of parts. So it's just an empty bin that has parts, and this is our CAD model for the parts. So now I'm just going to show you what the part looks like. So this is what the part is, and I need to show the material so that I can see what it looks like in real life. This has to be done outside of this project, just so that we just save time in the project, so that we save time from showing how to apply a texture. So let me start with render settings. So here I only am going to generate 3 images for the sake of time, but for the webinar I've generated 200 images so that I have big data set full of annotations for our AI to train. These file paths are auto-generated, auto-populated when I create a new project. And so now the resolution for the camera parameters is based on the background image. So our background image had pixels of 726 into 464, which is why I put them here. Our lens based on the camera lens, which is a 2.3 megapixel, 12 millimeter camera. So our sensor width is again from the, so our cameras within our structuralized scanner are 2 Basler cameras, and the sensor width for these cameras is 9.2 millimeters into 5.8 millimeters. So I got that from the product, Basler product page for that camera. This value here is the working distance. So from the camera to the bin, and it is 864 millimeters. So this all of this information is important to get a good rendered image. So here we're going through the light settings. So to set up best light conditions that reflect real life images taken from our camera. So I've just added 2 lamps just so that I get good lighting, and I've just this is just a style that makes our lighting good. At least I've chosen this style because I found this to be the best style. I've changed the light strength to vary from 80% to 120% so that each image is going to have varied lighting, and it's going to be very good to have different lighting so that we are accounting for different light conditions. I'm using predefined colors just so that lighting is not too varied. Here, I'm going to go through object settings. So I am scaling the object because we created a CAD model of the part as we did not have a CAD model. So Blender, you do not need to, so you need a CAD model, but you can also create a CAD model of the part, and we just had to scale it up so that it's as it has the same dimensions as the real life scenario. I'm going to generate in a rendered image. We're going to generate between 150 to 400 images per class. So each class is basically a top side, which is this side, and a bottom side, which is this side. So just so that we have so many parts in the bin, which is what our in a webinar I've packed a bin full of parts, so it's going to look similar to what I've set up a webinar for. I'm not going to restrict rotation in the X, Y, or Z because we want the rotation of we want the part to have rotations that depict a normal random bin full of parts. I'll show you how I define our walls for our bin. So it's just, I'm just going to select this area and then finish setting up a wall, and that's all you need to do. We can skip over these settings and move on to setting key points, which is basically how we set direction angles for our annotations. So as I told you earlier, this is our top face. So I'm going to set key points that are in line, that are straight, essentially, so that I get a good direction angle. And on the other side, I'm going to do the same thing. All right, so let me save that. And now let me show you how I create the classes. So I'm just going to call this a top class and a bottom class. So now I'm going to set this direction from 0 to 1 as our annotation direction. So that's basically our angle vector here, 0 to 1. And then for the other side, it's going to be the bottom side. The direction is going to be between 2 to 3. So that's what I'm going to do right here. So our direction, or I mean our plane of axis, basically the part, the direction axis that's coming out of the part in the top face is the Z, but inverse. So which is what this direction is right here. So I'm going to select Z inverse, and in the bottom face, it's just the direction that's coming out of the part, as you can see, is Z. So I'm going to keep it like that. So I'm going to set our object visibility. So what our object visibility is how much of the part do you see in the rendered image. So something like this would be 100% of the part, which would be 1. 0.5 could be something like where just half of the part will be seen, like right here. Or it could even be something like this, where this could be 0.5 object visibility, where only this, basically the number of 2D points or of the part visible is what object visibility is means. So now that I'm done with this, I am going to save these classes, and I'm going to just show you what I'm trying to do. I'm just trying to rename classes so that they are easier to comprehend and understand. And so this section right here is let me show you in a bit. So let me first animate and show you what a bin full of parts looks like right now. All right, so this is a bin full of parts, and let me show you the rendered image. So this is what the rendered image looks like. And I messed around with the light settings to make sure that I have these images that looks very similar to a real image. So this actually does look like a real image. So I'm good to go. I don't have to change any settings. So I'm just going to show you what I mean by so when I click on generating, I'm basically going to generate images in in a folder. So let me just say yes and start generating some images. So I can just merely move on and show you how the images look like in AccuPick. So in AccuPick, the images look, so these images that I'm showing you right here are real images, but the generated images are something like this. So as you can see, we have so many annotations. These are all automatically generated. And I have told you, as I told you earlier, I generated 200 images. So 200 images with annotations for both the top and bottom classes. And this helps because you do not have to say, this project auto labeling only takes about an hour or two, whereas you'll be saving time from manually annotating all these parts. So the next step would be to start deep learning and training our AI model so that we teach our software what a top class and a bottom class is and what the direction angles should be for these classes. So let me now show you our filters block. This is where we are able to set settings or limits for our picks for our top and bottom classes. And I'm able to do it for just each class individually or just for both classes. Our robot script block is where we set settings for our robot and set missions basically. So for example, let me quickly go over this. So I've set missions for both our start pick top and start pick bottom, which are basically picking the top and bottom classes to go to a pre-target position, which is essentially in this case, I've set it to be 100 millimeters over the part. And so the robot moves 100 millimeters over the part, and then it goes and picks the part right here, where it moves right straight to the part, and then our suction cup, the air turns on and then it picks it up. And then there's a wait time to let it pick it, make sure there is contact, and then it goes back to the pre-target and moves out of the way of the camera. So it's the same essentially for the start, pick, bottom. Our drop missions are just going to a specific bin. So dropping on top is dropping into one of the blue bins that you might see in the video, in the video feed, and the drop pick bottom is moving to the second bin and dropping it off. So let me also show you what the different robots that we're able to integrate with. So we're able to integrate with ABB, Danzo, Mitsubishi, Nachi, and a bunch of different robots right here. So here today I'm using a UR10, and the scanner that I'm using is a Solomon 2.3 megapixel 12 millimeter lens scanner. All right, so let me show you essentially what this looks like. So right now I was just trying to show you how I'm able to scan this recognize without actually moving, picking with the robot. And so this is what it looks like. I'm only making it pick one part or recognize one part per picks, just so that it's easier for processing time. So now I'm going to show you how flowchart looks when I play, which is basically, when I play this, it's basically going to start running the robot mission. So we start with capture block where it takes an image, and then this is recognition. And now, as you can see, the robot's going to pick up a part. Right now, it's pick up a top class, and now let's see what else is now. It's going for a bottom class. This is how a flowchart works. Let me show you what it looks like in the live feed. Generated in every pick. A pick point is generated in every cycle. So if you guys have any questions now, we are done with the presentation, and so please feel free to ask. You could ask in the chat as well if you want to, or you could ask the question. Thank you, guys. So I have added a message on the chat about the email address that you could email to if you have any applications vision applications that you would need help with, 3D vision applications. So as I told earlier, we have AI-based inspection, we have random bin picking, we have vision-guided robots. So this could be depalletizing, palletizing, random bin picking, manufacturing applications, and so on. Okay, so if no one has any questions, I guess we can end the meeting, and thank you for joining. Hope to hear back from you guys. Hope you guys have a great rest of the week. Thank you.